but I think we have to see the whole question in order for the final parts to make sense. Okay. So we get given the following demand and supply curves in the lobster market, and we are then asked to calculate the equilibrium price and quantity in this market. So we find the equilibrium by setting demand equal to supply. So price and quantity on those axes. So all I do is I take this demand curve and I take this supply curve and I set them equal to each other. So I get 540 minus 0.9 Q equals 0.9 Q. So the reason why I'm getting rid of the S and the D is because we know that in equilibrium, QS equals QD is some equilibrium quantity. Okay, so then I take the minus 0.9 Q to the other side, and I get 540 is equal to 1.8 Q. And then I divide both sides by 1.8, so that I'm left with an answer for Q. And 540 divided by 1.8, I'm just going to open my calculator quickly. So 540 divided by 1.8 is 300. So the quantity is 300 in equilibrium. So that would be the value there. And then in order to get the price, we sub that into either of those equations there. So subbing quantity of 300 into either the demand curve or the supply curve should give us the same price, because that's what equilibrium implies. So the easiest one to plug it into is the supply. So price is equal to 0.9 times 300, and 0.9 times 300 gives me 270. Okay, everybody happy with that answer? So 300 and 270. So in a test, this would be around 3 marks. Where the marks would be awarded is you would get a mark for calculating the quantity, a mark for calculating the price, and a mark for showing the correct way of getting to these answers, which is to make demand and supply equal. Then the next question says, if the price in this hypothetical lobster market is 90 Rand per lobster, will there be an excess demand or excess supply, and how large is it? So if we're talking about an excess demand, it means our quantity demanded exceeds our quantity supplied. And if there is an excess supply, it means the quantity supplied exceeds the quantity demanded. So what we need to do here is we need to sub in 90 Rand into both of these equations, solve for QD and QS, and then compare the sizes of those QD and QS values. And that will then tell us whether or not there is a shortage or surplus in this market. So an excess demand is the same as a shortage, and an excess supply is the same as a surplus. So what I do is I say 90 is equal to 540 minus 0.9 QD. And then I'm going to solve for my quantity demanded. So I take the minus 0.9 QD to the other side, and then I take the 90 to the other side. So I get 540 minus 90. Just make sure your microphones are muted. Okay, because I can hear somebody speaking in the background. Right. So then we have 0.9 QD is equal to 450. So that must mean the quantity demanded is 450 divided by 0.9, and 450 divided by 0.9 is 540, if I'm not mistaken, but let me just double check. So 450 divided by 0.9, oh, sorry, 500. Yes, so 450 divided by 9 is 50 times 10 is 500. Okay, so we have a quantity demanded of 500, and then we do the same thing to get quantity supplied. So 90, which is the price, is equal to 0.9 quantity supplied. So this one's pretty simple. I then just find that 90 divided by 0.9 is equal to the quantity S. And so that tells me that 100 is the quantity S. So now what I have is my QD and my QS. Clearly, the quantity demanded exceeds the quantity supplied. So there is an excess demand. Demand exceeds supply at this price of 90. And there's an excess demand of 400, and it is lobsters. So that is the excess demand when there is a price of 90. Now, I should have expected to get that answer, because if I go back to the picture here, if I just draw in a very rough idea of 90, so I'm being very, very rough here in my sketch, what you would see is that at a price of 90, that is below the market equilibrium price of 270. At 90 Rand, that would be the quantity supplied. And at 90 Rand, this would be the quantity demanded. And so we should expect to get a shortage or an excess demand. So just by sketching it really roughly, you already know that your answer should agree with an excess demand or shortage. So it's always good to draw yourself rough sketches, because that way you can make sure that your answer that you get agrees with what the theory would predict. Everyone good with this up until now? You can just give a thumbs up. Just want to make sure I'm not going too fast. Thanks, Ms. Achade. Thanks, Mr. Boardman. Okay, great. So now we're going to go to 1.3. So 1.3 says, how would this situation differ from your answer in 1.2 if the price per lobster is 450? So again, I'm just going to go back to my sketch. If the price is 450, what we should now expect to find is that at 450, this down here is going to be my quantity demanded, because at 450, that's the QD. And at 450, this down here is going to be the quantity supplied. So we should expect that at a price of 450, there would be a surplus or an excess supply. So in this question, when it's asking how will the situation differ, we know that it would now be an excess supply or a surplus. Now, the question isn't being completely clear in whether or not they want the calculations from you, if they want exactly what the supply, the excess supply is, but I'm going to calculate it nonetheless. In a sense, it's always kind of better to give too much than too little. But if this question was for only 1 mark, you could then read into it that they just want this answer. They just want to know, is it now still a shortage? Is it now in equilibrium, or is it now in a surplus situation? Okay, but I'm going to work it out just so that you can see how it would look. So how would the situation differ? So we just repeat the analysis here, but we now put 450 in for the price. So 450 is equal to 540 minus 0.9 QD. I'm just going to skip a few steps, and what I would get is that QD is equal to 540 minus 450 over 0.9. So what I've done is I've taken the minus 0.9 QD to the side. I've taken the 450 to that side, and then I know that I'm going to have to divide by 0.9. And so what I get is that the quantity demanded is 90 over 0.9, which is 100. And now with the supply, 450 is equal to 0.9 QS. And so 450 divided by 0.9 is the quantity supplied. And that's exactly what we had here. And so the quantity supplied is 500. So now we have exactly the reverse situation. We now have an excess supply of 400 lobsters, because now the quantity supplied exceeds the quantity demanded, which indicates a surplus. Okay, now I'm going to go to 1.4, and this is where we bring the tax into the picture. So this was the question that somebody asked me to do specifically for the revision today. So there's going to be a tax of 180 Rand per lobster. So we call this a per unit tax. It means we apply exactly the same tax value to every unit that is produced. So how this looks visually is we have our original price and quantity. Okay, I'm going to actually draw it a little, try and be a little bit more accurate in how I draw this now, just because it helps to then see how the supply plus tax curve comes from the supply curve. So how do we draw our supply plus tax curve if we have our supply curve? So our supply curve was given by price equals 0.9Q, which means that if quantity is 0, price is 0. So that tells me that there is a 0 intercept here. And so this supply curve is an upward sloping line, and it has a slope of plus 0.9. The demand curve is given by price is equal to 540 minus 0.9Q. So it has an y-intercept of 540, and then it is negatively sloped by minus 0.9. So it has roughly the same slope as the supply curve, just in the reverse. And then we found that the market is in equilibrium at a price of 270 and a quantity of 300. So this is where we start prior to the tax being introduced. When there is a tax of 180 introduced, it means that if the supply curve represents the minimum price that a seller is willing to accept, then if I'm charging 270 Rand when I produce 300, it means that the last unit produced, at minimum, I need to get 270 Rand for it. This represents the marginal cost of producing that 300 lobster. So this is all work that you're still going to do in the producer theory part of the course, but it is stuff that you already did in Economics 114 last year. If now I, as the seller, have to pay 180 Rand of tax to government once I have sold all my product, so this comes after the fact, it means that I need to build that per unit tax into my cost of production. So the tax isn't like a direct cost of production, so it doesn't form part of the marginal cost of producing, but it is a cost that I need to account for. So it means that when I sell that 300 unit that cost me 270, I need to build that 180 tax into that plan. So that means that the minimum price I'm now going to be willing to accept for the 300 units is going to be 270 plus 180, which is 450. So I'm putting that tax on top of my supply curve. That's why we call it the supply plus tax curve. So every single unit is going to have that 180 built in. In other words, we're going to end up with a supply plus tax curve that lies exactly 180 vertically above the supply curve. So every single vertical distance between the supply and tax curve is this 180 tax. So these two lines are parallel to each other. There's just been a upward vertical shift. So if this intercept was 0, it means that the new intercept here is 180, because every vertical distance between the supply plus tax and supply curve is this 180 tax. So then that means that my supply plus tax curve is going to have the following function. It is going to be the supply curve plus the tax. So we're just increasing the intercept by the value of the tax. In this case, the intercept is 0, which means the supply plus tax curve simply becomes price equals 180 plus 0.9Q. If my supply curve had had some positive intercept, so let's just say, for example, if my supply curve had been 100 plus 0.9Q, then the supply plus tax would have been price equals 280 plus 0.9Q. So I'm just shifting my intercept up by that per unit tax. Okay, so this is now my supply plus tax curve. And so where does the market now end up being in equilibrium? It ends up being in equilibrium where the supply plus tax curve intersects the demand curve. So in order to find the equilibrium price, we now need to set demand, which is this function over here. So we need to set demand equal to supply plus tax. So those are the two equations we're going to make the same. So 540 minus 0.9Q is now equal to 180 plus 0.9Q. I'm going to take the 180 to this side, so 540 minus 180, and I'm going to take the minus 0.9 to this side, which gives me 1.8Q. And so what I end up with is 360 is equal to 1.8Q. And 360 divided by 1.8 is 200. In other words, the market now moves to an equilibrium in which 200 lobsters are being sold. So the effect of a per unit tax is that the quantity in the market falls. We then now also have a new price, and we expect that price to be higher than the 270. So I sub this 200 into either of my demand or supply plus tax curves. So if I sub it into my supply plus tax curves, I get price is equal to 180 plus 0.9 times 200, which is 180 plus 180, which gives me 360. So is everybody happy with this question? I can move on to 1.5. I will try, let me try make the doc-cam full screen. That is a really good question. Does that, let's see, full screen. Does that help? Okay, I'm just going to joining on my phone so that I can make sure that I can see the chat, because once this is full screen now, I can't keep an eye on the chat. Okay, so everyone's happy with this question 1.4, so I can move on to the next question 1.5. You can just again give me some thumbs ups and then I will know. Okay, perfect. Great. Okay, so then in 1.5, we get told to find out the share of the per unit tax that is being paid by the sellers. So if I look at the question now, what I can see is that the original price was 270. The price that is now paid is 360. That gives me really important information. That tells me that buyers are paying 90 Rand more than they did before. Okay, so their price has gone up by 90 Rand. The total tax is 180. So if the total tax is 180 Rand and buyers pay 90 Rand more than before, that must mean that the remaining 90 Rand of the tax must be paid by the sellers. So what we found out here is that sellers have been able to pass 90 Rand of the 180 Rand tax over to the buyers. So sellers pay 90 Rand of the 180 Rand tax. And 90 Rand of 180 Rand is 50%. So the seller's share of the tax that they pay is 50%. In the picture, how I could have identified this as well is I could have seen that this was the equilibrium with the tax. Sellers are the ones who pay that full 180 over to the government. So buyers are indirectly paying some of the tax. It's not like the sellers say to the buyers, okay, you used to pay 270, you pay me 90 Rand more because you're paying 90 Rand of the tax. It's that they're just passing that tax over to the buyers. And then the sellers are the ones who take the responsibility of paying the full 180 over to government. And what that then means is that the value here, the price given by their supply curve at the new market quantity, represents the price that sellers now receive. So even though sellers technically get 360 Rand in the till, they only end up with 180 Rand at the end of the day. Okay, so this is where you can see the rough sketch. I mean, those numbers are the same, but again, this is a very rough sketch. So they only actually get 180 Rand. So that doesn't mean that they are getting 180 Rand less than they should. It means that they, in an original equilibrium without the tax, would have got 270. Now they only get 180. And so that tells us that they are only receiving 90 Rand less than they used to. And so that 90 Rand represents the portion of the tax that they take responsibility for. Does that make sense? So you can just give me a thumbs up if that all sounds good. Okay, great. Thank you. My laptop seems to be struggling under the weight of this video. So you should see a little bit of a delay in the video. Don't worry, it's just because the video is actually just taking up a lot of memory at the moment. Okay, so now I'm going to move on to the next question, which was requested, which is question 1 from tutorial 4. So question 1 on tutorial 4 tells us that there is a consumer, Sam, who spends 160 Rand per week. Oh, sorry, Ms. K-Stain says, can you also use the formula? Yes, so you can also use the formula, which is given in the memo to the tutorial. So I'm just going to quickly go back to 1.5 because this question refers to that. So the formula that you can also use to calculate this burden of the tax is, I'm just quickly pulling it up. So the formula that you can use is equal to, sorry, I'm just quickly running through my tutorial memos. It is going to be, I mean, if I just think about it intuitively, so let's say this is your price without the tax, and this is your price with the tax. So what that means is that, and let's say this is the tax. It means that when we take the price that buyers now pay, sorry, that's this one. If we take the price that buyers now pay and we subtract the price that they used to pay, this tells us how much of the tax the buyers are responsible for. Okay, so this is the tax burden on buyers. Okay, if I deduct this from the full tax, that tells me the tax burden of sellers. Okay, so if I take the tax burden of buyers and subtract it from the total per unit tax, that gives me exactly the part of the tax that sellers are having to pay. And if I divide that by the total tax, that's going to give me the share of that burden. So the share of the tax on sellers. So if we just apply this to the question we just did, the per unit tax is 180. The price with the tax is 360. The price without the tax was 270. And if we divide that by the tax of 180, we get 180 minus 90 is 90. Over 180 is 0.5. And that's where the 50% comes from. Does this formula now make intuitive sense? So, Mustaine, you can just say yes in the chat, or you can tell me if I need to go over it again. So the other question is, are you paying 360 per lobster, or is it 360 for 200 lobsters? Okay, so it's 360 per lobster, because when we work with a demand curve and a supply curve, what we're trying to find is what is the equilibrium price and how many lobsters end up getting bought and sold. So this tells us that after the tax, 200 lobsters are bought and sold, and each lobster is sold for a price of 360. If you wanted to know how much in total sellers of lobsters are making from lobsters, that is a different question. So if I wanted to know how much in total revenue are sellers making after the tax, I would then say they're making 360 Rand per lobster times 200 lobsters. So it's 360 Rand per lobster and 200 lobsters are sold. Okay. Okay, so now I'm going to move back to tutorial 4, question 1. So Sam spends 160 Rand per week. So this is his income M. And he spends this 160 Rand on 2 products, orange juice and apple juice. We then get told the prices of these 2 products. Orange juice is 20 Rand a cup, and apple juice is 10 Rand a cup. Sam views 1 cup of orange juice as a perfect substitute for 3 cups of apple juice. Okay, so this type of example is working with perfect substitutes. And it means that our indifference curves are going to take a very particular shape. How our indifference curves are going to look in this example is they are going to look like linear lines. Actually, that sounds tautological, or it's redundant. So indifference curves are linear. They are straight lines. Okay. So I'm going to explain to you now why that is the case. The reason is because if in your mind as this consumer, if you have 1 cup of orange juice, and instead of having that 1 cup of orange juice, you may as well have had 3 cups of apple juice. That tells me that 1 cup of orange juice is equal to 3 cups of apple juice in terms of the benefit it gives Sam. So when Sam consumes a cup of orange juice, he's getting some utility from that. If instead of getting the utility he got from 1 cup of orange juice, he replaces that 1 cup of orange juice with 3 cups of apple juice, he's going to get exactly the same utility from those 3 cups of apple juice. That then tells me that when he consumes 1 cup of orange juice, he gets a certain amount of marginal utility from that cup of orange juice. So remember, marginal utility represents the additional utility received from an additional unit of that good. Okay, so when he consumes a cup of orange juice, he gets some marginal utility from that cup of orange juice. And that marginal utility is exactly equal to the marginal utility he gets from a cup of apple juice multiplied by 3. Okay, so the benefit of a cup of orange juice is 3 times the benefit of a cup of apple juice. And if I rearrange this slightly, I then get that the marginal utility of orange juice divided by the marginal utility of apple juice is then 3. The other way I could represent this is that the marginal utility of apple juice over the marginal utility of orange juice is 1/3. So this tells me that the relative benefit of a cup of orange juice is 3 times more the relative benefit of a cup of orange juice is 3, and the relative benefit of a cup of apple juice is 1/3. So clearly this person prefers orange juice to apple juice. So now when he's going to make the decision about how much apple juice and how much orange juice to consume, that decision is going to be made by comparing the prices of these two things. So if we think about it intuitively, if he gets 3 times the benefit from 1 cup of orange juice than he got from apple juice, an orange juice in this example costs only 2 times what a cup of apple juice costs. It means that he's having to only incur twice the cost, but for that double cost, he's getting 3 times the benefit. Okay, so if I represent that also theoretically, what I'm saying is that the price of orange juice divided by the price of apple juice, which is 20 Rand over 10 Rand, is 2. Okay, so his benefit of orange juice relative to his benefit from apple juice exceeds the cost of orange juice relative to the cost of apple juice. And so this makes orange juice more attractive to him because he's getting more benefit for what he's having to pay. Okay, so how I can also represent that is I can say that if MUO over MUA is equal to 3, and we know that this is greater than the price of orange juice over the price of apple juice, which is equal to 2, what I'm going to do is I'm going to cross multiply. So I'm going to not change this inequality. I'm just going to move this MUA to the position of PO, and I'm going to move price O to the position of MUA. So I'm just going to do a little cross multiplication. And what I then end up with is that the MUO over the price of O must then also be greater than the MUA over the price of A. That tells me that at the margin, whatever I get in benefit from orange juice per Rand I spend on orange juice is greater than the benefit I get from apple juice for the last Rand I spent on apple juice. And that tells me that orange juice is more attractive. So as a rational consumer, as somebody who is looking to receive the most satisfaction they can get in the most affordable way, it makes sense then that Sam's optimal consumption bundle contains only orange juice. So he will only consume orange juice. And what that means is that the 160 that he is available to spend on orange juice is going to afford him 8 cups of orange juice, and he's going to consume no apple juice. So his optimal consumption bundle per week is going to be 8 cups of orange juice and no cups of apple juice. Does that make sense? So I've done a whole lot of theory here in order to argue why this is true. So you can give some thumbs up just to indicate that that makes sense. Or if you need me to re-explain something, you can just let me know in the chat. Can I just explain the last step? So, Mr. Chanu, do you mean just explaining this here, how I got the 8 orange and no apple juice? Or do you mean this step here with the cross multiplication? Okay, so I'm just going to write this without the values. If you had, for example, 2/3 is greater than a half, right? So if you had this here, 2/3 is greater than a half. And if I move the 3 to this side and I move the 1 to that side, that doesn't change the arrangement. That still gives me 2 is greater than 3/2. Okay. So the cross multiplication exactly tells us that we can just switch these two values and it won't change the way that these two sides of the inequality are related. Okay, so that's the cross multiplication. The bigger question is, why did I do the cross multiplication? So why did I switch price of orange juice here with the marginal utility of apple juice here? The reason why I did that is in order to get Gosson's second law. So when I write the marginal utility of something over the marginal utility of something else, what I'm representing here is the MRS. So whenever we're looking for an optimal bundle, we compare the marginal rate of substitution, the slope of our indifference curves, to the relative price of the two products, which is the slope of the budget constraints. If we find that the MRS exceeds this relative price, we would say that we are at a position where we are not optimizing because these slopes are not equal. The other form that I can put this rule into, so tangency would imply that these are equal, so that's something I'm looking for. That tangency condition would mean I'm optimizing. The other way that I can represent this is in terms of Gosson's second law. So Gosson's second law says, instead of comparing the MRS to the relative price, let's compare the marginal utility per rand of the two products. And that will give us the same conclusion. So if the marginal utility that we get from spending 1 extra rand on X is equal to the marginal utility that we get from spending 1 extra rand on Y, that is exactly the same condition as making my MRS equal to my relative price. So I did this cross multiplication in order to reason with Gosson's second law, which tells us how does the marginal utility per rand compare. Could we think of the MUX over price X as how much we value X? So value has to do more with the benefit. So when we are taking the marginal utility of something and dividing it by the price, what we're saying there is, if I had to spend just a little bit more on this thing, I would get some utility. So how much value can I get out of just a little bit more money spent on this product? That's how you should think about the marginal utility represented as a ratio of price, is how much additional value could I get out of consuming this thing if I spent just a little bit more on it? Okay. Ms. Volatia asks, could we still get marks if instead of using the notation, we just calculated the total we'd spend on each and then just deduced from there that since consuming 1 OJ is 20 and 3 AJ is 30, we would only consume OJ because it's cheaper? So I would not approach that this way. And the reason why I wouldn't approach this question by simply looking at the prices is because, okay, so I actually get what you're saying. So what you're saying is that if one orange juice is worth 20 Rand to me, and instead of buying that one orange juice, I could have instead bought 3 apple juices. Because in order to make me as happy with one orange juice, I need 3 apple juices. So one orange juice cost me 20 Rand and 3 apple juices cost me 30 Rand, which means apple juice is getting me, is going to cost me more to get the same satisfaction. Yeah, that's perfect. That reasoning actually reduces to comparing this to this. It is identical. You're basically just reasoning with the same mathematics. You're just not directly using the mathematics. The reason why I'm showing you the math, why I'm showing you the theory in detail, is because depending on the way the question is asked, you may not be able to use the logic of comparing the price and utilities in the way that you have put in the chat. So I'm just showing you everything around this way of thinking, just so that you can see how it all relates, because the question may actually force you to use a different way of reasoning this. Does that make sense? So by all means, that would be fine for this question. You would get all the marks. But I just want to be sure that I give you all of the theory so that when you're studying, you don't just rely on one method of doing it. And that means that depending on the question you get, you won't get the right answer. Okay, that's a really awesome question. Thanks for asking, Ms. Volatia. The other question is, can I please re-explain how you got the 8? Okay, so how I got the 8 orange juice and no apple juice was to reason that this person, based on how much value they get from orange juice and apple juice, and based on how much it costs them to buy orange juice and apple juice, we have concluded that this person is only going to consume orange juice. That's the conclusion we come to. And so if this person is only going to consume orange juice, we then need to know how much orange juice would he then end up buying with all of his income per week, which is 160. So that's where I found that if I take his income of 160 and I divide it by the cost of an orange juice, I then get 8 cups of orange juice. So that's where the value of 8 comes from. But in order to fully represent his optimal bundle, you would have to say he optimizes by consuming 8 cups of orange juice and no cups of apple juice. Okay, so that's where the 8 comes from. How this would look in a picture, so how these indifference curves would look, is if this person has orange juice on the x-axis and apple juice on the y-axis. What it means is that his indifference curves are going to be straight downward sloping lines. So let's say this is I1, this is I2, and this is I3. And the slopes of all of these indifference curves is going to be -3. That's going to indicate that he is always willing to give up 3 apple juices for 1 orange juice. So in order to get 1 extra orange juice, he is always willing to give up 3 cups of apple juice. So the slopes of these lines are all -3 because that represents his marginal rate of substitution. Okay. What we have now found is that he's going to end up at a corner solution along his x-axis because his budget constraints is not as steep as these indifference curves. These indifference curves have a slope of -3, but his budget constraint is going to be 160 is equal to 20O plus 10A. And so his budget constraint, if I represent this as A as a function of O, his budget constraint would be A is equal to 16 minus 2O. That would be the function of his budget constraints. And we can see that that has a slope of minus 2. So his budget constraint would be not as steep as his indifference curves. So his budget constraint, for example, could be this line here. And so this ends up being his corner solution. That ends up being a point like 0 apple juice and 8 orange juice. So a person who consumes perfect substitutes, where they get different marginal utilities from each unit of that product consumed, and those products have different prices, depending on the size of that benefit relative to the cost of consuming that thing, we would end up in a corner solution. And in this case, the corner solution puts us at a place where we only consume orange juice. Question 1.2 then says, suppose the price of apple juice rises to 20 Rand a cup. How much additional income would Sam need to afford their original consumption bundle in 1.1? Okay, so let's reason through this. The price of apple juice goes up to 20 Rand. We have already said that he optimizes by consuming 8 cups of orange juice and no cups of apple juice. So if the price of apple juice goes up, is this going to affect him? Absolutely not. His budget constraint would change. If the price of apple juice goes up to 20 Rand, his budget constraint will change, but the logic still remains. If his marginal utility from orange juice is still equal to 3 times the marginal utility of apple juice, and the price of an orange juice is now the same as the price of an apple juice, what that means is that if he wanted to replace his orange juice consumption with apple juice, it's now going to cost him 3 times more. So he's not going to consume any apple juice. And so the conclusion is his income doesn't need to change at all. Nothing needs to change because he isn't consuming apple juice in any case. And so why does he need more income to consume something that is more expensive, but he doesn't in any case consume? Okay, so the answer to 1.2 is his income doesn't need to change at all. Thanks, Mr. Van Roy, for this is great. So whenever someone asks a question in the chat, by all means, you can answer them, the other student. That really is awesome. So the question was, please, could you quickly elaborate a bit about the meaning of a corner solution? And Mr. Van Roy answered, when a consumer maximizes utility by spending their entire budget on only one of the available goods, resulting in 0 consumption of the other. Awesome. Perfect answer. Okay, then the next question says, how would Sam's optimal consumption bundle change if the price of apple juice fell to 5 Rand? Now things are going to be different. So if the price of apple juice is now 5 Rand, the price of an orange juice is still 20 Rand. What this tells us now is that when I buy an orange juice, I could have bought 4 apple juices instead. So the price of an orange juice is equal to 4 times the price of an apple juice. So 1 orange juice in cost terms is worth 4 apple juices. If I compare this to the benefit I get from orange and apple juice, if orange juice gives me 3 times the benefit of an apple juice, but an orange juice costs 4 times what an apple juice costs, that means orange juice is less attractive to me now. Okay, so the margin rates of substitution is still 3, but now the price X over the price Y is 4. So I'm not going to be optimizing if I only consume orange juice. In a world in which apple juice becomes 5 Rand, my best option, my optimal choice is now to consume only apple juice. So things have completely changed. So now when I only consume apple juice, it means I have 160 Rand to spend, and I'm going to spend it only on apple juice, which costs 5 Rand. And so I'm now going to consume 32 cups of apple juice and no orange juice. If I think about it in terms of the picture, if this was how my budget constraint looked before, it had a slope of -2. Now my budget constraint is going to be steeper than my indifference curves. My indifference curves still have a slope of -3, but now the slope of my budget constraint is -4. And you can see how that's going to end up in a corner solution where I only consume apple juice. Okay, so essentially, the relationship completely flips. Could you think of the MRS as the consumer's reservation option? So the marginal rate of substitution represents how willing am I to give up something in order to get something else. So it doesn't relate to a reservation price or a reservation option at all. It represents my willingness to trade things off against each other. So my marginal rate of substitution tells me how much utility I get from one thing, should I choose to buy one more of that thing, in terms of the marginal utility I'd get from the other thing I could have bought. So it doesn't have to do with a reservation option. It has to do with how my benefits from these two goods relate to each other. What is the relative benefit of the one thing in terms of the benefit, in terms of the other thing? Mr. Chanu asks, could we be asked what is the price of apple juice for the consumer to be willing to consume both orange and apple juice? Yes, by all means. That's a great question. You see, this is how we prepare for a test. We start to find out, okay, what else could we have asked? Because, yeah, this theory can all be related in different ways. Okay, so if the question is, how much would apple juice need to cost in order for the consumer to choose a bundle that contains both orange and apple juice? Okay, awesome question. So the price of an orange juice is 20 Rand. And we know that the marginal utility from one orange juice is equal to 3 times the marginal utility from an apple juice. If we are consuming both products in equilibrium, so when we are optimizing by consuming both products, that must mean we have a point of tangency. It must mean that we are somewhere in our picture where we end up at a bundle that has both of them. We're not at a corner solution where we only have one thing or only the other thing. So what I would then say is that it must then be true, if I consume some combination of both, that the marginal utility from orange juice over the marginal utility of apple juice must be equal to the price of orange juice over the price of apple juice. That has to be true. This is 3. Okay, because if I take marginal utility of A over to this side of that equation, I get MUO over MUA equals 3. So 3 must be equal to 20 over the price of A, which means that the price of A must be 20 over 3, which means that the price of A must be 6 Rand 67 cents. Awesome question. Love that question. Thank you so much for asking it. Okay, we're still going to do some of this theory and the questions that I still have lined up. So is it fine if I move on from this question on to the next one, where we're going to look at the example of perfect complements? So we're moving from perfect substitutes into perfect complements now. Awesome. Okay, so now we have question 3 from, question 5 from tutorial 3. So question 5 from tutorial 3 says, Brian spends his 3,000 Rand monthly income on 2 goods, coffee and sugar. His utility function is given by the following. Okay, actually, I'm just going to respond to Ms. Ngube's question in the chat. When we're given these 2 products, how do we know which one goes on the x-axis and which one on the y-axis? So in most cases, you will be told. In cases where you have product X and product Y, X goes on the x-axis and Y goes on the y-axis, okay? But in most cases, you will be told which one goes on which. When I drew this last question, when I drew the figure, I chose for orange juice to be on the x-axis and apple juice to be on the y-axis because of how I was representing my MRS. If you have the marginal utility of orange juice over the marginal utility of apple juice as your marginal rates of substitution, that means that orange juice, the thing that is in the numerator, must be on your x-axis, because this MRS represents how much apple juice I'm willing to give up in order to get more orange juice. So that must be equivalent to the change in A over the change in O. And if we're dealing here with a slope and it's change in A over change in O, then A, apple juice, must be on the y-axis. Okay. Mr. Chani, would you say the TUTs are very similar to the A1 or slightly more complex questions? I would say that the quality of the A1 questions and the TUT questions are very similar. The only thing that is quite different in the A1 is the appearance of MCQs. So the MCQs is where you have to then think a little bit deeper about your theory. So there it's a little bit more conceptual, a little bit more really understanding what the theory is about, which is why when I'm going through these TUT questions now, I'm focusing a lot on the theory, because I want to make sure that when you get to an MCQ question, for example, you are able to identify how all of these concepts fit together, because that's what the MCQs are going to be asking you to do. Okay. Okay, so tutorial 3, question 5. We have Brian who spends his 3,000 Rand monthly income on 2 goods, coffee and sugar. His utility function is given by this function over here. So the reason why somebody asked me to do this is because of the min here. Why the min? Okay, so the min just means that the value that this takes will be the minimum of these 2 numbers. So I'm going to explain that by going through the question, because I think it's going to make more sense once I start the question, why it is that we represent perfect complements using a min function. So question 5.1 asks, if Brian drinks 4 coffees with a teaspoon of sugar in each. In other words, he is choosing to combine 4C with 1S. That is his preferences, okay? What is his total utility when he drinks 4 coffees? Sorry, there should be 4S. Make such a big mistake there. So he drinks 4 coffees with a teaspoon of sugar in each. So when he drinks 4 coffees, he has 1 teaspoon of sugar in each coffee, which means he consumes 4 sugars. So the ratio that he's using is 1C with 1 sugar. So he always drinks a coffee with exactly 1 teaspoon of sugar. What is his total utility? Okay, so we use this function here to find out his total utility when he drinks 4 coffees, and each of those coffees is drunk with a teaspoon of sugar, which means he also has 4 teaspoons of sugar. So his utility from coffee and sugar, in this case, is going to be the minimum of 4 and 4. And the minimum of 4 and 4 is simply 4. What if instead he had drunk one of the 4 coffees without sugar? That tells me that his utility now will be him drinking 4 coffees, but now one of the 4 coffees doesn't have sugar, so he only has 3 teaspoons of sugar. That would then give him a total utility of 3. The minimum of the numbers 3 and 4 is 3. So how does this represent perfect complements? I'm going to quickly sketch how the indifference curves for perfect complements look. So let's say this is cups of coffee on the x-axis, and this is teaspoons of sugar on the y-axis. If he drinks 4 cups of coffee with a teaspoon in each, that's going to be represented by a point there. If, on the other hand, he drinks his 4 cups of coffee with 3 teaspoons of sugar, he only gets 3 utils. So we should actually put utils here because that's more correct. He would only get 3 utils of utility. What if he drank 4 cups of coffee and 5 teaspoons of sugar? So if he drank 4 cups of coffee and 5 teaspoons of sugar, what would his utility be then? It would be 4. So if he drank 4 cups of coffee with 4 teaspoons of sugar, and he drank 4 cups of coffee and he had an extra teaspoon of sugar in one of them, he would be just as happy. In other words, these two lie on the same indifference curve. If he drank 5 cups of coffee and he only had 4 teaspoons of sugar, so one of those cups of coffee has 1 less or has no sugar, he would still get the minimum of 5 and 4, which is 4. So this would also be the equivalent of getting a utility of 4 utils. So that is also on the same indifference curve. So we can see that indifference curves for perfect complements have these right-angled shapes. This indifference curve represents a utility of 4 utils. This combination here, where he has 4 cups of coffee and 3 teaspoons of sugar, would lie on the same indifference curve as having 3 cups of coffee and 3 teaspoons of sugar, because the minimum of 3 and 3 is also 3. So there would be another indifference curve that has a right angle shape. And that indifference curve, I'll call it I1, corresponds to 3 utils of utility. So this is why we represent perfect complements using this min function, because it makes sure that if we look at this corner here, this little kink, let's actually call it a kink. If we look at that kink there, what we find is that being exactly at that kink where you're consuming in the ratio you prefer gives you the same utility as still having the same amounts of S, but having more coffee, or having the same amounts of coffee, but having more S. So this is how the perfect complements look. How would this look if this was a max function? If it was a max function, so let's reason through that there. So if it was max, then if it was 4 cups of coffee and 3 cups of sugar, 3 teaspoons of sugar, then you would get 4. So 3 and 4 would be 4. 4 and 4 would be 4. 5 and 4 would be 5. So those would they would move in this direction, I think. But max functions do not apply ever. Well, at least I've never seen a max function in the context of utility functions. We only work with a special case of a min function in order to represent the situation of perfect complements. Okay, so this is you would never be given a max function. You would only be given a min. Okay, 5.2 then says, if the price of coffee is 28 and the price of sugar is 2, how much of each good should Brian buy per month? Okay, so what we know is that Brian needs to always consume in the ratio of 1 cup of coffee to 1 teaspoon of sugar. Okay, so he's always going to be combining a cup of coffee with a teaspoon of sugar. So that means that when he combines his 2 products in the ratio that he wants, it's going to cost him a total of 30 Rand. If we think about the budget constraints as well, the budget constraint for him is going to be 3,000 equals 28C plus 2S. So that's going to give me 2S is equal to 3,000 minus 28C. And so S is equal to 1,500 minus 14C. So that's how his budget constraint would look. It's going to be a downward sloping straight line. So if I had to put this budget constraint in this example here, you see that the consumer is going to optimize by ending up at that kink. So they're not going to optimize ever by being on either the horizontal part of an indifference curve or on the vertical part of an indifference curve. By implication of how these indifference curves are shaped, he's always going to end up at a kink, which means that he's always going to do best by combining his 2 products in exactly the ratio that he prefers, which is a coffee with 1 teaspoon of sugar. So if he does best by combining these 1 for 1, and that costs him 30 Rand, it means that he would be optimizing when he spends his 3,000 Rand divided by 30, which gives me 100. So he would optimize by consuming exactly 100 cups of coffee and 100 teaspoons of sugar. And we know that that's going to also equal to his 3,000, because if I take 28 cups of coffee, sorry, not 28 cups, 20 Rand for a cup of coffee times 100, and I add that to 2 Rand for a teaspoon of sugar times 100 teaspoons, I end up with 3,000 Rand. So his optimal consumption bundle is going to be 100C and 100S. Okay. Does that make sense? Everyone now understand where the min function applies to these types of indifference curves for perfect complements. Why did you do the budget constraints? I just did the budget constraints just to prove to you that the budget constraint is a downward sloping line. So it's just to show you that if you had to imagine a downward sloping line together with these right-angled indifference curves, you should then see that you have to end up at an optimal point that combines these 2 products in exactly the way that he prefers, so 1 for 1. So you don't have to use the budget constraint to answer 5.2. I just included it here to justify why I solved it in this way. Okay, just so that you could see that a linear downward sloping budget constraint has to end up putting you at a kink. Does that make sense, Tetra? And then I just used it in order to prove also to you that the solution of 100 and 100 adds up to my total income. So these are just little theoretical checks that I'm doing, okay? Because I don't want you to take for granted that what I'm doing is not without reason. Okay, this is how I'm applying the calculations in a very reasoned way. I'm using the theory in order to drive the calculations I'm doing. Okay, then 5.3. We now get told that his utility function is now represented by a slightly different equation. It now has the min, but then it has this additional amount that is depending only on coffee. Okay, so this represents complements still. They just don't happen to be perfect complements in the sense that his utility here depends on how he combines his coffee and sugar together. But this bit here actually says, you know what? He's actually okay drinking drinking coffee without any sugar at all. So this represents a person whose utility depends on coffee and sugar, but more so on coffee. So he could get utility even if he consumed no sugar. Okay, so we're just adding a little extra bit of something to his utility function here. So 5.3 then asks, how much utility would Brian get if he drinks 4 cups of coffee, but one of them doesn't have a sugar in it? So this was exactly the same problem in 5.1. We said, what would he get if he drank one of the 4 coffees without sugar? And we saw he would only get 3 utils then. So by having 1 coffee without sugar, so only having 3 teaspoons of sugar makes his utility go down. With this utility function, his utility from having 4 cups of coffee but only 3 teaspoons of sugar is now going to be the minimum of 4 and 3, which is 3, plus 8. So now he gets 11 utils of utility from the same consumption bundle that in the past only gave him 3 utils. That tells us that he gets additional utility from consuming coffee alone. So even if he had no sugar, so let's say he wakes up one morning and he's run out of sugar and he drinks a cup of coffee, how much utility could he get from a cup of coffee even without any sugar? Well, he would get min 1, 0, so 0, plus 2 times 1, which is 2. So that tells me that he gets some utility even without sugar. So he gets additional enjoyment. It's just the same way of saying the same thing. So he gets additional enjoyment from coffee that is separate from sugar. Okay. Everyone happy with question 5 from tutorial 3? Can I move on to the next question? Okay, great. So I'm going to now move on to a question that now uses a utility function that is neither for perfect substitutes nor perfect complements. So we're now using a utility function that would give us smooth, nonlinear, or convex indifference curves. So this utility function here, which is uxy is given by x times y, this is a Cobb-Douglas type utility function, which is a very typical utility function that gets used because it does give us indifference curves that are convex and asymptotic to the axes, which means that if you had to consume nothing of either of these goods, you can't get any utility. So you will never end up at a point where y is 0 or x is 0. because your utility depends on having something of both of them. So you can see that if I put 0 in for x here, I'd end up with a utility of 0, because 0 times some positive number would be 0. And if I had absolutely no y, but some amounts of x, I would get no utility, because 0 times some positive number is 0. So this is our more conventional utility function. Her income is m equals 40. The price of good y is 2. And the price of good x is initially 4. It then asks us to determine her marginal utility of x and her marginal utility of y. So the marginal utility of x represents how much additional utility would I get if I had to change my x by a little bit. This is what a partial derivative represents. It represents how much will utility change given a small change in x. So when we take the partial derivative of our utility function with respect to x, we are calculating the marginal utility of x. The same thing for the marginal utility of y. The marginal utility of y is going to be what I expect my utility to change by when my consumption of y changes by a small amount. So if I take the partial derivative of this utility function with respect to x, I treat y as a constant. So all I'm doing there is I'm making x the only variable in this function. So if I take the first derivative of x times y with respect to x, I'm going to be left with y. It's the same as if, let's say, this was 2x. If I was taking the first derivative of the function 2x, 2 would just be the number. And so the first derivative of 2x with respect to x would be 2. It's the same thing here. Y is just now a number. It's some constant value. So the mu of x is y. Applying the same process or the same reasoning, we then have that the marginal utility of y means I treat x as a constant. And so the marginal utility of xy with respect to y is going to be x. So those are my marginal utility values. What that then means, and this isn't part of the question, but I'm just adding this, that then means that the marginal rates of substitution is going to be the marginal utility of x over the marginal utility of y. So we assume x is the variable on the horizontal axis, which is why the marginal utility goes in the numerator. So the MRS is going to be y over x. Okay. Question 2.2 then asks, determine her initial best affordable bundle given her preferences, income, and the prices of X and Y. Okay, so how do we find a consumer's best affordable bundle? A best affordable bundle depends on two conditions being met. The first condition is you spend all your income. In other words, whatever combination of X and Y you consume has to exhaust all your income. You have to be on your budget constraints. The second condition is that your marginal rates of substitution, the slope of the indifference curve, must be equal to the slope of the budget constraint, Px over Py. In other words, we're looking for a point of tangency. So if I had to represent this very roughly, let's say I have these two indifference curves, and then this is my budget constraints. That point there satisfies condition 1. I'm on the budget constraints. So I'm spending all my income on X and Y. So that's, yeah, meeting condition 1. But it doesn't meet condition 2 because the slope of my indifference curve and the slope of my budget constraints are different. So that's why this isn't an optimal point, because it only satisfies one of the conditions for a best affordable bundle. This is our best affordable bundle because it is on our budget constraint, which means it uses up all the income. So yes, condition 1 is met. And at this point, my budget constraint is tangent to a highest attainable indifference curve. And so condition 2 is also met. Why I'm explaining this to you is because knowing that this is the two things that need to be true to be at a best affordable bundle tells you how to solve any question asking you, what is the best affordable bundle? Given income, prices, and now we have the MRS from the first part. So her best affordable bundle, I'm going to start with condition 2. So it has to satisfy that MRS equals price X over price Y, which means Y over X, which is my marginal rate of substitution, must be equal to 4 over 2, the price of X over the price of Y. If I rearrange this to only have Y or X by itself on the left-hand side, I'm going to get that Y is equal to 2X. So what I have here is a condition that tells me that wherever I end up, it has to be a place where I'm consuming twice as much Y as I am consuming X. Okay, so by using this condition, I have managed to find some relationship between Y and X in my optimal bundle. The other condition, which is to spend all your income, I'm now going to use this together with what I found here. So spending all my income means 40 must be equal to 4 times X plus 2 times Y. That's my budget constraints. All I'm going to do now is I'm going to sub this in for Y, because I now know that Y must be 2X when I am optimizing. So now I have 40 is equal to 4X plus 2 times 2X. And so 40 is equal to 4X plus 4X, which is 8X, which tells me that I'm optimizing when I consume 5X. So now I know how much X I should be buying. How much Y should I be buying? Well, I already know it needs to be 2 times my X. So Y is 10. So my best affordable bundle is going to be 5X and 10Y. So I have used the two conditions for an optimal bundle in order to solve this mathematically, which means you now don't need to memorize a method. All you need to understand is what are the two conditions for me to be at a best affordable bundle, and just use those together with the numbers in order to solve for the optimal outcome. The Lagrangian is exactly this. Okay, the Lagrangian gives us this and this. So somebody asked me just to show the Lagrangian, so I'm going to do that very quickly now. And to show you why, the Lagrangian gives us these two conditions that mean we can do the math really simply. And then we don't have to do the Lagrangian because the Lagrangian gives us this easier method. Mr. Boardman asked, do we have to indicate a star for the best affordable bundles above X and Y? You don't have to. As long as you tell me that this is the best affordable bundle, you don't need to do that. Okay. If you want to, I'm totally fine with that. It's not going to make a big difference because at the end of the day, what we're asking you to find is how much X and how much Y. So it's totally up to you. I'm happy for you to use it or not to use it. Okay, so how does the Lagrangian give us these two conditions? So the Lagrangian tells us that in order to optimize, we need to be maximizing the difference between the utility we get and some penalty that is applied to overspending. Okay, so this is what the Lagrangian is about. It's about finding the values of x, y, and lambda that make the difference between the utility we get and a penalty for overspending. So this is what we spend, this is what we have. We want to try and maximize that difference. Okay. The question in the chat asked, do we have to use a Lagrangian? No, because as I'm going to show you now, this is where the Lagrangian leads us. So you can start here. But if in the test I ask you to show me the Lagrangian for a particular problem, you're going to have to show me this. So that's why I just, wanted to make sure that you understood how the Lagrangian is set up. So when we do a Lagrangian, we take the partial derivatives with respect to this Lagrangian, with respect to each of our variables that we need to optimize on. So the things we need to find maximums for. So we're taking 3 partial derivatives. And we need to take these partial derivatives and set them equal to 0. So if I take the partial derivative of this Lagrangian with respect to x, the partial derivative of a utility function with respect to x is the marginal utility of x. That's exactly what I showed you earlier, right? I said that when we take delta u over delta x, so the partial derivative of this function with respect to x, we're getting the marginal utility of x. If I then take the partial derivative with respect to x of this function here, if I multiply this lambda in, I'm going to get minus lambda price xx minus lambda price yx. Ooh, not xy. Oof, that was a bad typo. So that should have been y. Plus lambda m. So the only thing in here that has an x in it is this term here. So these are all constants when I am taking a derivative with respect to x. So I don't even have to look at these because they are constants. When I take the first derivative of constants, they become 0. So what I'm going to have is minus ux minus lambda price x. So taking the first derivative of minus lambda price xx with respect to x means I just take this constant that is now in front of x. And when I set this equal to 0, what you end up with is, if you had to rearrange this, you would end up with lambda is equal to mux over the price of x. I think you can see where this is going. Okay, now if I take the partial derivative of lambda with respect to y, someone asked, does the letter D have to be like that always, or we can write it how it is normally? So I don't mind if you write it as a D like this, but technically it isn't correct because we are taking partial derivatives. And so the notation for partial derivative is a D that looks like this. Okay, so I'm just being technically correct here. But if you wrote a regular D in the test, I'm not going to be bothered. Okay, but mathematically, the mathematical notation requires me to use this D. Okay, so if I take the first derivative of the Lagrangian with respect to y, if I would take the first derivative of the utility function with respect to y, I get the marginal utility of y. And if I take the first derivative of these 3 terms with respect to y, that's a constant, so it becomes 0. That's a constant, so it becomes 0. And then if I take the first derivative of minus lambda py y with respect to y, I get minus lambda py. and I'm going to make that equal to 0. And if I rearrange this, I get lambda equals MUY over the price of Y. Lambda and lambda are the same. In other words, one of the conditions for an optimal solution is that MUX over the price of X must be equal to the MUY over the price of Y. That's where this condition 2 comes from. It comes from the Lagrangian. And then the last one, taking the partial derivative with respect to lambda, if I do that, there's no lambda in here. So this is all a constant in the eyes of lambda. And then I have minus lambda pxx. So there's a lambda. Px and x are constants because now I treat x as a constant. So I have minus px x, and then minus lambda pyy with respect to y gives me minus pyy. And then the first derivative of plus lambda m with respect to lambda is plus m equals 0. And if I rearrange this, what do I get? M is equal to price xx plus price yy. That is condition 1. Okay. Same question, but now asking about the writing the L. If you write it as a capital L, I also don't care. Okay, you can write it as a capital L. So I'm just using very particular mathematical notation here just because, yeah, it is more suitable. But in the case of the test, I wouldn't care if you write an L or a D. It's totally fine. Okay, so I hope what you can see now is that the Lagrangian is the basis for why we do this. Okay, so that's why I say you don't have to do the Lagrangian. You can just go straight to this because this is the Lagrangian at the end of the day. Okay, everyone happy with that? Can I now move on to question 2.3 of this question? Okay, so I see some thumbs up, so I'm going to do that. Okay, so how much utility does she derive from her best affordable bundle? So we see that her best affordable bundle is 5x and 10y, which means we have to substitute 5x and 10y into her utility function, which is x times y. So if I put 5 and 10 in there, I get 5 times 10, which is 50. So she gets a total utility of 50 utils. Okay. Now the next part of the question is where we take this and we combine it with the price effect and the substitution and income effect. So I'm going to show this by also drawing graphs so that I can hopefully convince you why the math looks the way it does. Because when you see the math next to the graph, it becomes more clear how the math and the graph are actually doing exactly the same thing. So the question says, suppose that the price of X increases to 5. So the price of Y is still, just going to get the numbers from the previous page. So the price of Y is still 2, and her M is still 40, and the MRS is still Y over X. Okay, so I'm just putting those values up there to help guide what I'm going to do now. So what is Louise's best affordable bundle following this price increase? Okay, now I've put a hint here. Her budget constraint changes. So what I'm going to do is I'm going to repeat the analysis from 2.2, but in this step here where I substitute into the budget constraint, I need to now use a different budget constraint because spending or M no longer uses this budget constraint. Spending or M relies on a different budget constraint because one of the prices has changed. So now her MRS must be equal to price X over price Y, which means Y over X must now be equal to 5 over 2, price X over price Y. So this is a new relationship because the price has changed. So that means that Y is now 2.5x based on the new prices. My income is now still 40. My price of Y is still 2, but my price of X is 5, which means my budget constraint is 40 is equal to 5x plus 2y. And so I sub this in for Y there, and I get 40 is equal to 5x plus 2 times 2.5x. And so I get that 40 is equal to 5x plus 5x is 10x. And so my answer for X is 4. So the effect of the price of X going up is that I reduce my consumption of X. My old budget, my old best affordable bundle, so old, I'm just going to say best affordable bundle, my old BAB was 510. My new best affordable bundle has 4x. I now need to find out how much Y based on this value of X. So Y must be 2.5 times X. So Y is equal to 2.5 times 4, which is 10. So my Y hasn't changed. So my X has gone down, but my Y has stayed the same. So how could I visualize this in a picture? So if I have X on the Y-axis and Y on the Y-axis, and my original budget constraints was M, so M was 40, price Y was 2, and the price X was 4. So my original budget constraint would have had a Y-intercept of 20, and it would have had an X-intercept of 10. My new budget constraints, so I'm drawing this quite dramatically. My price X is now 5. So my new budget constraint would have an X-intercept of 8. 40 divided by 5. And this wouldn't have changed because my income and my price of Y stayed the same. And now what I found is that after this price change, so originally my X was 5 and my Y was 10. So this was my initial best affordable bundle. And now with the new price, I'm going to end up over here because I'm going to end up with 4x and I still have the same amount of Y10. So the change has taken me to a bundle like this. Okay, so the movement from here to here, so I'm going to label this A and I'm going to label that D. The movement from A to D is my total price effect. When the price of X increased, my budget constraint pivoted inwards. And what I've calculated using the math is that took me from a best affordable point of 5x and 10y to a new best affordable point of 4x and 10y. So the total effect of the price change on my consumption of X and Y is the total effect on consumption of X is -1. I consume 1 less X. But my total effect of the consumption on Y is 0 because I still consume 10 units of Y before and after the price change. So this math is simply doing what the graph could also visually achieve if we had pivoted the budget constraints inwards. Everyone with me on this before I move to the next part of the question? Okay, great. I have thumbs ups. So the next part of the question then says, okay, but what were the substitution and income effects? So now we have to use the Hicksian decomposition. So the first thing I'm going to do is I'm just going to do a rough illustration of how the Hicksian decomposition works. I'm going to use it not in the context of this question, but just theoretically, because I just want to show you how it works so that when I do the math, you can see why the math, essentially. So why the math I'm doing. Okay, so let's say we have our two products, X and Y, and we have some initial budget constraints, budget line 1, and we are initially optimizing by finding a point of tangency between this budget constraint and some highest attainable indifference curve. And so we optimize by consuming X1 and Y1. So the initial optimal bundle is X1, Y1. I'm going to label it A. Okay, so A is the initial optimal bundle. I'm also going to assume that both X and Y are normal. And this is going to make a difference for how I draw the graph from this point onwards. Okay, so if we have the budget constraint B1, and now the price of X goes up, it means that the budget constraint is going to pivot inwards along the axis for X. So here's my new budget constraint, B2. I'm not going to draw my best affordable point yet, because I first want to explain the mechanics of the substitution and the income effect before I do that. So the substitution effect of a price change tells us, how does the consumer change their consumption of X and Y given the new prices, but holding utility constant. So the substitution effect tells us if we could still achieve the same level of utility, so if we could still stay on this indifference curve, how would we choose to consume X and Y? Because the prices of X and Y have changed. At point A here, our marginal rate of substitution was equal to the price of X over the price of Y, which originally was 4/2, which was 2. But now the price of X over the price of Y has changed. The price of X has gone up, which means now at A, this is no longer true. Faced with the new prices here, our MRS, which is still 2 at A, because that's the slope of the indifference curve at that point A, is now smaller than the price of X over the price of Y, which is now 2.5, 5/2. So I'm just going to use the prices to help us think through this. So that means that if the MRS is smaller than the relative price, we would substitute away from X towards Y. And the way that I reason through this is as follows, is that if the MRS is also the MUX over the MUY, and this MUX over MUY is smaller than the price of X over the price of Y at A, that would imply that the marginal utility of X divided by the price of X is smaller than the marginal utility of Y over the price of Y. So if I had to swap the price X and the MUY, just like I was doing earlier in this revision. So if the MUX over the price of X is smaller than the MUY of the price of Y, that means Y is now more attractive. I could get more utility per rand spent from consuming more Y than I get from consuming more X. So it makes sense then that I would move along my indifference curve in this direction, where I'm giving up X in order to get more Y. So the way that I can find that using the functions in the picture is I take my new budget constraint and I move it parallel outwards until it becomes tangent to my old indifference curve. So this is a hypothetical income change. Like what we're saying here is that given the new prices, so the slope of this represents my new prices. If I could go back, the movement from A to C is the substitution effect. So when I made this hypothetical change, so when I'm pushed my new budget constraint parallel outwards to my original indifference curve, and I find the point where my new prices that I face are equal to my marginal rate of substitution, that is where I end up moving to as part of the substitution effect. So the substitution effect is consume less X, consume more Y. And that makes sense because X now looks more attractive to me and Y looks less attractive to me. So that is my substitution effect. My income effect tells me how does the consumer change their consumption of X and Y given the change in their real purchasing power. So the income effect has to do with now that prices have changed, am I now relatively wealthier or relatively poorer than I was before? So what I can see is that given this price increase in X, my feasible set has shrunk. So my feasible set used to be all of these bundles underneath my original budget constraint B1. Now my feasible sets are only the bundles underneath B2. So that tells me that my purchasing power has decreased. When you have a decrease in purchasing power, you will buy fewer normal goods and you will buy more inferior goods. And because I have assumed that both X and Y are normal, it means that both of the income effects for X and Y need to be negative. Because I'm showing how would this person's consumption of X and Y change responding to a lower purchasing power. And because these goods are both normal goods, I would respond by buying less of both of them. So the income effect is what takes me from my substitution effect to my new best affordable point. So I'm going to draw my new best affordable point at a point like that because this corresponds with a negative income effect. So once I'm at C through substitution, I further decrease my consumption of X because my real purchasing power is decreased. So that change was my substitution effect. This change was my income effect. And the overall change is my total price effect. This point also corresponds to a negative income effect for Y, because going from C to, I'm going to label this D. So going from C to D also gives me a negative income effect for Y, and this was my positive substitution effect for Y. And so my overall total effect for Y is negative, and the reason why the total effect is negative is because the income effect dominates the substitution effect, the way that I have drawn this picture. So my negative income effect is larger than my positive substitution effect, which is why my total effect is negative overall. Okay, so this is the theory of how the movements change. And I could finish this off by just drawing an indifference curve that is tangent to my new budget line at that new best affordable point, D. So now that we have the theory to guide us, we're going to do the math of 2.6. So the question says, using the Hicksian decomposition, decompose the total effect on X, which we already found was -1, into the substitution and income effects. Round to 2 decimal places. Okay, now I've given a hint here as well. The substitution effect shows how consumption changes when relative prices change, while the level of utility is held constant at the original level. So here is the trick. I want my utility that I get from X and Y to still be 50, because that is the amount of utility we got at the previous best affordable bundle of 5X and 10Y. So I still want my utility to be 50 in total. And that 50 has to be equal to X times Y. Okay, so this is a condition that has to be true. I also then know that when I am at point C here in the substitution effect, my MRS must be equal to the new relative prices. So my MRS must be equal to 5/2. In other words, Y/X, which still is my MRS, must be 2.5. So Y must still be the equivalent of 2.5X. So now I've got Y in terms of X, and I can now substitute this in here. So I have 50 is equal to X times 2.5X. And so 50 is equal to 2.5X squared. I divide both sides by 2.5 and I get 20 is equal to X squared. And that must mean that the square root of 20 is the value of X at my substitution effect, once that substitution effect is completed. And so the square root of 20 is equal to, just pulling up my calculator quickly, the square root of 20 is 4.47. So now I know that the value of X at C is 4.47. So A was my original best affordable point. My X value was 5. C is where I moved to with the substitution effect, and my X value is 4.47, which means that my substitution effect on X is equal to 0.53. Actually, to be most correct, minus 0.53. So the substitution effect means I reduce my consumption of X by 0.53 units. I get that 0.53 by taking the 4.47 away from the 5. And then the income effect is going from where I ended up through the substitution effect down to my new best affordable point. And at my new best affordable point, I calculated that my X must be 4. So that movement from C to D is my income effect. And so my income effect on X is minus 0.47. That's what takes me from 4.47 to 4. So here I've shown you exactly how the math matches with the graph. Does that make sense to everybody? This is where seeing the graph and the math side by side really helps to understand why it is you do the math in this way. How did we get to X equals 4? So X equals 4, we got in question, just pulling up my previous question 2.4, I think it was. Yes. So in question 2.4, we found that given a new high price of X of 5, we end up at a best affordable bundle where X is 4 and Y is 10.